number 2, section 5, we're going to use the binomial theorem. So before, when we were using Pascal's triangle to find the coefficients, we had 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? And depending on what power we're going to, we'd go to the 7th row if we're looking at this one, right? Binomial expansion here. And so we would go down to the 7th row and look at those coefficients. Well, another way to do it is use the binomial theorem that does the different combinations that you can do. So say if you have 5 friends, and from those 5 friends, you're choosing 2 to go to a concert with you. So how many ways can you rearrange those 5 friends, right? So that's the idea of a combination. Okay, so this one I can rewrite, and the formula for this is choose combination. C is for combination. We have our n for how many total we're choosing from, and then the total number possible, and then r represents how many of those choices we're going to make, like 5 friends and we're choosing 2. So n choose r. And this is in your calculator. I'll show you maybe on the next example or in class. Is n factorial divided by r factorial times n minus r factorial. Okay, and this factorial exclamation point just means if I start like 4 factorial, that means 4 times 3 times 2 times 1. So whatever number's in front of it, you always start there and you just multiply all the way down until you get to 1. So if we have the Chicago Cubs here and they played the Atlanta Braves 6 times and they won 3 and lost 3, and we want to know what the likelihood of them, if they're winning or losing, what's the probability. Okay, so I'm doing an expansion here of wins and losses, 50-50 shot, right? So what we're looking for, but there's 6 games that they played, so a power of 6. So if I expand this, I could use Pascal's triangle to find all these coefficients, or I can use this binomial theorem. So here we have a total choice of 6 games, right? And we're going to choose 0 games to start. So that'd be like if they won all of them, right? So W to the 6, they won all of them and no losses, right? The next one would be 6 choose 1. So this would be they won 5 of them and lost 1 of them. And then the next one would be 6 choose 2. So here we have wins now as 4 and losses are 2. And then this keeps on going. And this is how 6 choose 3. So that would be 3 and 3, which makes sense. Losses, because that's where we're looking for. What's the probability of that? Same amount of losses, same amount of wins. And then we can keep on expanding this until we get to our full total list of possibilities, right? How many games they could have played. And then 6 choose 4. So that would be 2 wins, 4 losses. And then 6 choose 5, which would be 1 win and 5 losses. And then the last one would be 6 choose 6. So if I'm choosing 6 people out of 6 people and I have 6 tickets, there's only 1 possibility, right? So that would be no W's and 6 losses. Okay, so then I can do on my calculator, or I can use this formula to figure it out. So this one would be 6 factorial over 0 factorial, and then n minus r, so 6 minus 0 factorial. So what that looks like is 0 factorial is defined as just 1. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 1 times 6 factorial. Right, so 6 times 5 times 4 times 3 times 2 times 1. Right, so those are all going to cancel out. And then I have 1 over 1. So this is 1 and W to the 6th. This one, when I do that one, or by my calculator or the same way, I get 6W to the 5th L plus this one is going to be 15 W to the 4th with 2 losses. And then here's where I'm kind of after, right? What's the probability of getting 3 wins and 3 losses, right? Same likelihood as win is to lose. So this one, when you do this one, it would be 6 factorial over 3 factorial, and then 6 minus 3 factorial. Well, this is 6 factorial, which is 6 times 5 times 4 times 3 times 2. and then 3 factorial, and then another 3 factorial. Well, here I can't multiply 3 times 3 and get 9 factorial. This would be 6 times 5 times 4 times 3 times 2 times 1. This one would be 3 times 2 times 1. And then this 3 factorial will be 3 times 2 times 1. So these I could cancel out, right, because they're the exact same. And then here, 3 times 2 is 6, so I could cancel with that one. So then I have 5 times 4 divided by 1, which is just 20. So there's 20 with 3 wins and 3 losses. So that's the one I'm after, right? So there's 20 possibilities of 3 wins and 3 losses. Okay, but then how many is the total possibility? Because probability is always over some kind of total. Well, here how I find out the total is I just add up all my coefficients up front. That would be the total possibilities. So plus 6WL to the 5th plus 1W, no W's, L to the 6th. So 1 and 7, so that's 7. So that's 22, 42, 42, 57, 63, 64. So out of 64. So 20 out of 64 would there be their probability of winning at least half, 3 games with 3 losses. So winning half and losing half. So which is about close to 0.31, which is about 31%. So they have about 31% of the Cubs winning 3 games and losing 3 games against the Braves. So the different combinations that they could have won all 6 games once. They could have won 5 games 6 times. They could have won 15, or they could have 15 different ways they could have won 4 and lost 2, 20 different ways they could have won 3 and lost 3, 15 different ways they could have won 2, lost 4, 6 different ways they could have won 1, lost 5, and then 1 different way they could have just lost all 6, right? And so that's the total number. That's where we got 64 from. And then the 20 is how many of those did they win 3 and lost 3, and so that's 31%. So this is just a different way to find out different combinations. You know, you could have just did this by hand by counting. Okay, they played 6 times. They could have won all 6. They could have lost all 6. Then they could have won 5. How many times could they won 5? How many times could they have lost 1? And so that's where we use this binomial theorem.